gentlemen. Our project is about incorporating blockchain into the medical device supply chain to improve supplier management, specifically auditing and document control. My name is Michelle, and I'm a graduating senior studying biomedical engineering at San Jose State.
My name is Denice. I'm also a senior studying biomedical engineering at San Jose State University.
My name is Hussein, and I am also a senior in biomedical engineering at San Jose State University.
This is an overview of what we plan to talk about today. First up on that list is biomedical motivation, so I'd like to pass it on to Denice.
So in talking to a lot of suppliers and a lot of OEMs, we realized that there is a challenge in the medical device industry, specifically in their supply chain. There's no traceability. If I talk to a supplier today, he would have a hard time identifying his raw materials guy or where the device is actually going to the patient. So we believe that there is a need for this in industry. There's a need specifically with regards to the OEM and third-party supplier, because the third-party supplier could be in different locations around the world. And communication with them becomes a lot more challenging, especially in the need to audit them, to make sure that they are a good supplier for their company. So we believe that traceability throughout the supply chain, specifically between OEM and third-party supplier, would facilitate this audit trail. It'd make it easier for them to verify that they are actually a good candidate for their systems, as well as ensure that they're doing what they've said they've done.
So the objective of our project was to increase the trust and reliability within the medical device supply chain by creating a blockchain infrastructure that allowed OEMs to better manage their suppliers. So before we go into detail about our project, we wanted to give a brief background about blockchain. So blockchain is a decentralized and distributed ledger that records transactions. When a new transaction is created, a new block is formed with information regarding that transaction. That new block is then linked to an older block with older transactions, and this creates a trail of edits that can be followed back to the original block. Some desirable qualities of blockchains are they're immutable, they're tamper-proof, they're auditable, and they're consensus-driven. So what consensus-driven means is that changes require approval by a majority of the network, and this is done to prevent fraudulent or corrupt information from entering the network. Some examples of current applications of blockchain are in the food supply chain, in the financial industry, in tracking diamonds, and the pharmaceutical industry. There are also several potential applications in the medical device space. There are companies working on patient records, quality procedures, testing results, and hospital inventory, and making blockchain applications for all of these.
Moving on to FDA considerations, our product is not a medical device or software intended to be used by physicians or in direct contact with patients. Therefore, it will not be undergoing traditional regulatory pathways such as the 510(k) or pre-market approval PMA. This is an advantage because it costs money to file regulatory documents with the FDA, and because the product we're making does not undergo these traditional pathways, that necessity is eliminated. The ultimate goal is for this type of application to encompass all members of the supply chain, including the FDA, and it is used first in OEM and supplier communication to demonstrate potential. This is a list of requirements that are applicable, and some of the ones I'd like to highlight are 21 CFR 11, which is electronic records, and 21 CFR 820 quality system regulation, in particular 820.50, which is purchasing controls. This is straight out of 820.50, and the line of text that we're most interested in is evaluate and select potential suppliers, contractors, and consultants on the basis of their ability to meet specified requirements. The Code of Federal Regulations is mandatory, and companies that fail to comply are essentially violating the law. Failure to monitor companies could result in an FTA penalty. So in the case of audits, an inspector, when they discover nonconformances, they have the option of sending the letter a Form FDA 483 notice of inspectional observations, and failure of a medical device company to adequately and promptly respond to 483 could result in a warning letter, withholding of product approval or clearance, or facility shutdown. And so these are very, very serious consequences. Common causes of receiving a 483 are listed on the slide, and you'll notice that purchasing control procedures, which is what our product focuses on, is in fact on that list. So moving on to market research, it was definitely a hefty effort to get to where we are right now and to figure out this problem in the medical device supply chain industry. We performed market research as well as customer validation. So to do this, we attended networking events and talked to representatives from several companies that are listed on this slide here. What we found through these interactions was that OEMs can only purchase from their approved supplier list, also known as ASL, and this list can be extremely long, especially for manufacturers of capital equipment or complex products such as pacemakers and neurostimulators. While it's optimal to have many suppliers, as we increase the amount of suppliers, we increase the amount of money that a medical device company has to invest in maintaining that list. There's a specific type of suppliers known as critical suppliers, and they have to be audited annually and in person. And this is a very large investment of resources, both in terms of money and manpower. Several challenges that were brought to our attention was that auditing suppliers is challenging due to distance, as Denice mentioned earlier, as well as versioning, ensuring that contract manufacturing has access to the most updated version of an engineering design. So now moving on to design of experiments. To test the infrastructure of our blockchain, we focused on incorruptible, auditability, storage, and trackability. So with incorruptible, we wanted to make sure that when something was changed, that was reflected on all of the network. Under auditability, we wanted to make sure that, let's say an auditor comes to a medical device site, they can temporarily be granted access and the access can later on be removed. In terms of storage, we wanted hashes on the blockchain to correspond to that information somewhere else, and that information could be retrieved accurately. In terms of trackability, we wanted that once changes were made, they were reflected and documents couldn't be just changed without that type of authority. And these are the factors that we considered. As you'll see, a lot of the factors relate to the medical device companies, such as size, and the cost of the device they produce, as well as the cost of the device. In addition, it also reflects their approved supplier list, the amount of critical suppliers they have, as well as how many physical supplier audits they conduct in an annual year.
Now to materials and methods. We used 3 different platforms, 3 different systems to be able to bring our idea to life. We used IBM and Oracle's BM virtual box to have the back end of the system, and Angular for the front end. So step 1, creating the blockchain. IBM has created a hyperledger in response to the interest in developers for making blockchains, and that's what we were really dependent on as far as a template. Then we used Angular to modify the front end, what our user would be seeing, what they'd be interacting, and then connecting those two. So this is a brief overview of what our backend has. It has asset participants for their transactions, so the asset that will be shown for each participant, the transactions that will occur, the access and control rules for each person, and the query definitions of the person when they're doing the front-end questions to the back-end. This is all encompassing in what we call a BNA file, and this BNA file then talks to the front end via the Hyperledger Fabric Cloud and the Node.js.
Here we have screenshots of our Angular app, our Angular interface, which allows users to interact with the BNA file. So over here is the asset control file, asset control page, which allows users to create document assets, which then will connect to a document stored on a database somewhere else. This is our participants page. We currently have 3 participants which can be created. We have OEMs, contract manufacturers, and suppliers. We're also highlighting some code that is used, sample codes that are used in the creation of each interaction. We also, over here, what we are highlighting is the transactions we currently provide. We're currently trying to limit the number of transactions and functionality of the network because in the future we will be charged by the size of the file once we upload it to the IBM cloud. So what we currently limited ourselves to authorizing access and revoking access to documents. And for conclusions, we came to the conclusion that a system based on trust is not a very good system for the medical device supply chain. There is a need for traceability within and transparency within the medical device supply chain. We believe that blockchain has potential to improve the medical device supply chain and bring that traceability and trust to it. We also came to the conclusion that coding is somewhat outside of our skill set, so moving forward we would like to hand it over to a coder so that they can take care of that aspect.
So moving on to cost analysis, these are the material expenses, not including the networking events that we've attended. The main thing I'd like to highlight is IBM Cloud or IBM Blockchain, the first item on the list. As Hussein was mentioning, we were fortunate enough to not have to pay for that throughout the duration of our project. However, in the future, to increase the amount of information stored, we'll definitely have to do that. And this next slide are labor expenses. So if we were to get paid at $20 an hour, the cost would be around $43K.
So there's a cost analysis also for the future of this project. We are first to market, so it's been challenging to find a good cost structure of what we would be charging our customers, but it would be, of course, a dynamic cost. So our initial fee would be $800 per user, but this, of course, is changing because the cost to run a blockchain really depends on the amount of information that is put on the blockchain, as well as the more information, the more energy required to run it, and the more cost that is required to just have the blockchain be in, I guess, a long record of information. So there we have several manufacturing costs, distribution costs, marketing costs, but these are all ballparks, seeing from what we've seen from other industries, from other software industries, and what they've been charging. So for future work, blockchain is only as useful as the information that you put in. And to have this customer validation and customer security that the information that is put in is safe, we really depend on IoT systems. So IoT systems would directly be pulling information from the machinery, and whether that be pressure, temperature, any data that they request, and directly be put in the blockchain instead of relying on someone to manually be inputting data.
We would like to acknowledge all of the individuals who've contributed to our project and provided guidance, in particular our advisor, as well as the BME department. In addition, we would like to thank all of the industry professionals who have been very generous in sharing their knowledge and experience and are listed on this slide. These are some of the references that we've used. In addition, I'm pretty sure most of you have heard this little speech, but we do have a website and we've been documenting our project on it. You can access it by scanning this QR code or by typing this link into your web browser, and we are live on both mobile and desktop. At this time, if you have any questions, we'd like to address them.
Questions, anyone? So how fast would it take someone to set up the system if you wanted to use it? Like if I'm a company and I came to you guys and I'm like, oh, I think your service is very interesting. I have a client in China and I like to validate my supplier using the technology you've created. How long do you think it will take them to set it up?
Assuming the system has already been made and assuming all the bugs have been debugged, I think it would take us, it's not a base of time, it's a base of the quality of the output of the work that they're requesting. It would be highly dependent on how large the components are, how many multiple components they're looking at from different suppliers. Having said that, I think it would be probably a month to incorporate this one.
You mentioned Oracle system. What do you guys use it for?
We use the Oracle virtual box machine to run Ubuntu, which gave us an environment to actually run Hyperledger locally. Because otherwise, there is no way to run on Microsoft currently. We would otherwise had to buy a MacBook, run it on it, or format our computer and just install Ubuntu. So this was a way to get around it.
All right, thank you very much.